video. I thought, have you deactivated? Hassan.
There is a Bernard, there is a disruption in your voice. Yeah, there is a disruption and noise coming from your side.
Yes,
Hello,
you're
Bernard.
breaking a little bit.
So shall we start the interview, Bernard?
Yes, can you hear me?
Yes, I can hear you.
So over to you. Now, Bernard, you are the main interviewer and you will lead this interview. And I will be watching this one as an spectator. So over to you. If you want to open your camera, then you can also do this.
Yes, can you hear me?
Yes, I can, but you break up a little bit.
Hassan, thank you. I can't offset it. Open.
Yeah. It's a pleasure to be here.
Can you see me? Can you see me?
No, I cannot see you.
Jen. Hello.
Hi. Hello, Bernard.
Can you now see me?
No, I'm still not seeing your camera.
Try to increase your volume.
I think my volume is always to the maximum. I can speak louder.
That's okay. Yeah, that is okay. Thank you. Thank you very much. Let me take this opportunity to welcome you, Dr. Chen, to this assessment. I want to introduce myself. My name is Bernard Osiron. I'm a process engineer, and I'm speaking from right over here in Kampala, Uganda.
Awesome.
I would like to ask Hassan to introduce himself, and then you will also introduce yourself. As you introduce yourself, you tell us a little more about yourself. We would like to understand you, your education, qualifications, and any other relevant information that you'd like us to know.
Awesome.
Please, Hassan.
Yeah, hello all. This is senior process engineer working in a petrochemical plant, and I have around 10 years of experience of refinery plus petrochemical. Thank you very much. Over to Chen.
Oh, yeah. It's a great opportunity, and thanks for offering this opportunity for me. I'm a guy like always like designing and building things up. I suppose it's a nature for me. Become a chemical engineer. I studied at Colorado State University at United States and I graduated last year with my PhD degree in chemical and biological engineering. I have 7 years of experience in computational fluid dynamic and hydrodynamic analysis. During that program, I have hands-on experience with commercial software like ANSYS FLUENT and STAR-CCM, and as well as the open source software like OpenFOR. I have expertise with CFD analysis and FEA analysis of like multiphase flow, thermal fluid coupling analysis, phase changing, and turbulence modeling, and something like flow through a membrane. And I also have the experience with GPU acceleration to accelerate the CFD process. And I have a fundamental understanding of the transport phenomenon, heat transfer, fluid dynamics, and the flows coupling with chemical reactions. And I'm eager to work at your company, and now I'm ready for a new challenge. Thank you. That's it.
Thank you very much. That's so wonderful. And I'm really very glad to get to know you in person. Have you worked in the industry before?
Yes, I have. Yes, that is correct. I have. I
Which
worked
kind of
at
industry?
it's a chemical refinery plant. I worked as a process engineer as well back in China as an internship. After I got my bachelor degree.
Oh, that's so wonderful. Now we are going to talk about computational fluid dynamics. Maybe to give a brief background, computational fluid dynamics looks at the use of computers to model the behavior of fluid flow, right?
That is correct.
Yeah. From your experience, I would like you to share with us a scenario where you used your skills of computational fluid dynamics to identify a problem and where you modeled a solution for that problem and how you did it.
Absolutely. So a little bit of background of CFD. The flow and the fluid either is compressible or incompressible. When there's a pressure gradient, there's a motion, usually there's a motion of the fluid. And the motion of the fluid is governed by the governing equation and the so-called the Navia's-Stokes equation. So with the correct boundary condition, you can solve the partial linear equation. And because the equation itself is so nonlinear, so therefore we need computational fluid dynamics. It's a control volume method that you can discretize your fluid domain and then solve it and convert it to a big matrix. Therefore, what we can know from the CFD is that we can get the velocity field, pressure field, and the stress tensor field of the fluid domain. Basically, we got all the information of the fluid. Therefore, CFD helped us to actually know how the fluid will flow under certain circumstances. During my PhD degree, we had a project of modeling how the micro algae grows in an open pond that is recirculated by a paddle whale. And it is found out the internal mixing is so critical to the algae growth And therefore, we use the CFD tools to analyze and to visualize how the fluid flows in the pound. So that's a great example of how we can use it. And what we did is we use the transient, so it's time dependent with a time marching method, and we modeled the full motion of the paddle wheel using the unique boundary condition. And by that, we fully revealed how the fluid flows and the turbulence characteristics in the pond. And I did is I built a CFD result to MATLAB interface so we can visualize all the data set in MATLAB. And we came up with a concept of turbulence persistence length. Then we also have designed a unique passive vortex generators that does not require additional power input, but it can increase internal vertical mixing in the pound. And we also have validated that using CFD tool. It has helped in long the persistence length of turbulence by 80% and increase the productivity of microalgae by 15% to 10%.
That's so wonderful. I would like to know, how did you validate the results that you got?
Great question. So a little bit of joke, CFD is also called colorful fluid dynamics because it's colorful. Once you got the data, it's usually the fluid, the pressure field, and the velocity field. There are many choices you can have. There are already visualization tools built in commercial tool softwares like an ANSYS FLUENT. There's a program called ANSYS post-processing, where you can directly put your result in, and it will give you a nice, beautiful visualization figures. The other way is that you can convert the format of the result files and read it, use something called ParaView. That is another great tool. But what I did is I write it down in binary format and directly read it into the MATLAB. So it's for the velocity field, it's a vector field. So you have n by 3 data sets. For pressure, you get another n data sets. You read all of those things into MATLAB and use the MATLAB built-in functions to visualize and analyze the results. For example, you can plot the distribution of velocity fields. You can filter out all the regions that have low velocity magnitudes. You can highlight those regions in a 3-dimensional plot where you can figure out where the fluid flows most fast.
Well, computational fluid dynamics, in reality, it involves the transformation of
Hi, Hansis, are you there?
Yeah, I think it's his internet is lagging.
Yeah, that's what I
Let
thought.
let me chat with him.
your
Hello,
problem.
Bernard.
Yeah, you're back.
Yeah.
Can you repeat your question?
Yes, okay. Network issues. I was trying to say computational fluid dynamics involves the transformation of a physical problem into mathematical models. I want us to first go back a little bit to understand how we arrive at that step. I want you to specifically tell us, how do you identify a problem? Because I'm very much sure that you don't just come from nowhere and you're modeling. There must be a problem that you try to anticipate or something of that kind. What are these problem identification tools that you've used before? Dr. Chen.
Awesome, awesome. That's a great question. How to precisely defining a problem is always the first step of successfully solving the problem. First of all, we have to define a clear fluid domain. So, for example, there are many colleagues of mine that analyzing how the blood flows inside of the heart. So you do not need to model the layer of the heart. You only have to figure out the space that the blood is occupied. Another example would be the fluid in a pipe. So you do not need to build the physical model of a pipe. You only have to figure out what's the volume that's occupied by the fluid, which is a cylinder. And then once we know that, we have to define a clear boundary condition. And the fluid domain itself is a boundary condition. Other than that, we have pressure boundary condition, velocity boundary condition. So for example, a problem is the fluid in a pipe, and we give like 1,000 Pascal in one side, and no pressure and no restriction on the other side. We will apply the pressure boundary condition on this side. That helps the program solve the problem, and that is how we transform the real world physical problem into a conceptual computational problem. And other than that, there's another important aspect of CFD work is to use experimental measurements to validate the work. So, for example, if you are interested in how the fluid flows in a pipe, you can use different measuring tools to measure the velocity field at a certain cross section and get a generally knowledge about how the fluid will flow. It will have a parabolic profile. We all know that, but understanding a little bit about the result, what we are expecting, is also very helpful about the setup of the simulation, in case you want to get any non-physical result.
Okay. From your CV, I'm seeing a concept of HAZOP and FMEA, right?
Yes, that is correct.
What are these concepts and when do we use them?
It's the hazard prevention program. So that was happened when I was a process engineer. That our team have some hazard FEMA safety meetings that I joined them and participated in the process safety review. So what I did is I was in the chemical refinery plant, and the meeting was about review the current process and the current equipment setup, and find out if there are any possible issues that can cause healthy hazard. If all the valves are working, and what will happen if the valve got a malfunction? Do we have sufficient backup plans to make sure the employee is working in a healthy and safe environment? For example, there was a distillation tower, and the reflux valve is not reliable. And what if that valve is broken and malfunction? And if we lost that valve, all the fluid in the distillation will flow back up into the upstream equipment, which is a compressor. And if the fluid goes into compressor, pressure gets damaged. Therefore, we have identified another backup valve if the first one failed. So that situation won't happen. That was what we carried out in that review section.
Okay. I want us to talk about errors in computational fluid dynamics. From the process where you identify the problem to conceptualization up to when you model, there are associated errors that actually affect the accuracy of our model. Could you please identify some of these errors and how do we minimize them to ensure their accuracy is at least high?
I'm actually not quite understanding about the question. So you're asking where can the error come from and what can I do to overcome those errors? That's correct.
Exactly.
Okay, the error comes from several aspects. The first, I will representing your fluid domain precisely because there are so many conflict and complex geometry, and what we often use is to simplify those geometry. For example, if you want to model how the landing gear of aircraft will behave while it's flying, many of time we will simplify all the little tubes or the little electronic pipes of the landing gear, but only have a CFD landing gear model that is approximately identical to the physical one. They're always approximations. So those things you can get errors from that. The second, how you define your boundary condition clearly. We can, for example, for pressure inlet boundary condition, you're measuring the pressure correctly. Are they identical to the real measurements and physical readings? And other times, when you give a velocity inlet profile, the profiles like sometimes we just specify the velocity inlet is 5 meters per second. But actually, because of the nature of the turbulence, the profile could be parabolic, could be something else, and it's very hard to fully identify the accurate profile of the velocity field. That's the second one. The third one is how you discretize your fluid domain. The finite volume method requires you to cut up your domains into little tubes and solve and convert the non-linear problems into a linear one, and use progression method to find out the fields. But you can only get as accurate as how you discretize your fluid domain. In terms of the CFD world, you can get a higher and much better resolution with 1,000,000 cells over 1,000 cells. That is how much you pay and how much computational cost you have paid. The fourth one would be the error accumulated from the algorithm. The error accumulation and for the mesh, the error most comes off the mesh. There are certain requirements for the mesh. If the mesh is highly skewed, or it's not conformal, or it has a weird aspect ratio, then the error can propagate. The fourth one is induced from the algorithm itself, from the time matching method. For example, if you're using the first order time matching method or second order error time matching method, or using the fifth order some advanced time matching method, that can induce some errors. In terms of how we overcome those errors, for the first one, we will measure as precisely as we can of the fluid domain or the dimensions. The second one would be choose the boundary condition smart, testify different boundary condition and see how the result will become. The third one would be use the scalability method. So for example, we will partition the fluid domain into say like 1,000 cells and run the results, and then discretize it into like 10,000 and run the result, and then 1,000,000 cells and run the results, and compare the results and see if it's converged to a unique solution. If it is, then we know that probably 10 million cells is sufficient for this. For the last one, it's always a trade-off between the accuracy and the stability. That also requires some knowledge and skill to fine-tune up the simulation. If you use some higher order time matching method, it might be internally not stable. And if you use too much mesh, use a mesh that is too fine, and you set up the step size too big, the simulation could just diverge in several steps. And that's my answer about how the errors are induced and the method we can do to overcome those errors.
Yes, Dr. Chen, you talked about the NaviaStocks equations as the partial and nonlinear equations that we develop to represent the physical phenomenon. And you said that upon the transformation of these Navier-Stokes equations to linear algebraic equations, we then use the computer software to get the model solutions. I would like you to tell us what are some of the key principles underlying the Navier-Stokes equations?
Great question. Navier-Stokes equation is derived of the conservation of momentum fluid. It has several terms. The first one is time derivatives terms. Tells you the momentum change in controlled volume during the time. The second term would be convection term. That is how much momentum is carried by an upstream fluid with the controlled volume into your problem controlled volume. And the third term is the diffusive term. That's how much momentum is carried out because of the diffusion. And on the right-hand side, I believe there's a turbulence dissipation term. That is how the momentum or any other quantity you might interest. It could be concentration, could be velocity. and how much that quantity is dissipated due to the viscous effect. So that is the underlying of Navier-Stokes equation. And usually Navier-Stokes equation is coupled with the so-called continuity equation. That equation basically tells you it's derived of mass conservation. If you define a control volume that the mass change respect to time in that controlled volume is equal to how much mass flow inside minus how much mass flow outside of the control volume. The next question would be the principle of how we linearize this equation, right?
Definitely.
Yes. So if we look at Navier-Stokes equation, there's a divergence term and there's a gradient term, and there are partial differential terms like partial u, partial t, or partial u, partial x. The way we attack this problem actually is developed in the 1970s. The idea we used to linearize this problem is we linearize each term, use mathematical transformations. For example, partial u, partial x. So that's the gradient of the velocity in one magnitude that we can use finite difference method. So it would be like UA minus UB divided by the coordinates of A minus B. Then we get an approximation of partial U, partial X. For the divergence term, then the gradient term is a little bit more complex. We have to use the divergence theorem first to convert the divergence term into a gradient term, and we have all the mathematical tools that we can use to approximate the gradient fields. And once we express that, you can find out all the unknowns in the problem that can be converted to a larger number set of linear equations. And with the correct boundary condition, you can find out the number of unknown is actually equal to the number of equations. And then it becomes a matrix conversion problem. So you can use some higher end advanced technique or use a Gaussian method to find out all the unknowns. And by that way, at that time, we just solved the pressure field and the velocity field from the matrix inversion problem. So,
well, Dr. Chen, I would like to understand what could be some of the key considerations that you put at the forefront when you're developing CFD models.
yeah, break up a little bit. Can you repeat your question?
Have you understood my question?
Yeah, can you repeat it?
Yeah, I'm trying to ask that while modeling CFD solutions, there are some key considerations that you put at the forefront. What are some of these considerations? At least two.
Course directions. Can you define that? What is course direction?
What do you consider as being most important while modeling CFD solutions?
Okay, so the significance of why we're using CFD or other methods?
No, key factors that you consider as being very important when you're modeling modeling CFD solutions.
So the aspects that are considered that is important
Yes.
in getting CFD result and accurate CFD data. There are several aspects. There's no. So first off, you need to get a reliable CFD package. Either it's you wrote it or it's commercialized software. The software itself should be, there should be no major bugs in it. A popular one would be ANSYS FLUENT, OpenFOAM, STAR-CCM, and there are many other packages that is especially used in certain fields. I believe NASA has itself CFD packages. That's the first one, get a good software. Second, get a good computer. The software itself is almost all the cases parallelized. So you can run using multiple cores at the same time. So having a good high performance computing resource allows you to solve the big scale problem in a short time of manner. The second one. The third one is getting a good CFD engineer like me that can clearly identify the problems and set up the simulation and validate the simulation is fit. I think that's pretty much it. That's the several most important things in CFD. Get a good software, get a good computer, get a good employee.
All right. How often do you think a CFD engineer should update CFD models? Or is it really necessary to update these models?
What do you mean by define, update the models? Like update the knowledge of the model or update
the models? What I'm trying to mean is when you model a CFD, is there a need to keep updating it or there is no need? If there is need to update these models, how often do you think a CFD engineer should update these models?
Yes. Are you saying how often to update the softwares or updating the mathematical model?
The mathematical models.
Great question. That depends. That depends on the model. There are continuing achievements that have been done in the fluid dynamics community. People come up with better models of modeling turbulence, modeling diffusion, modeling particle interactions with fluid, modeling thermocoupling fluid. People just come up with more and more equations in this field. In terms of update those models, I think what you can do is get the latest version of software. And because there are so many models available and there is no such thing as this model is better than that model. It's just
Dr. Chen, let's take an example of a process, a chemical process, and today you've modeled, you've transformed the physical behavior of the fluid flow into a mathematical model today. Do you think after 5 years that model will still be valid?
That's a good question. It should be, because the CFD simulation results should be validated with the experimental result. So if they are close, then I believe they are still close after 5 years.
Sure. How do you consider the concept of dynamism in a process flow? Because when you're modeling, you are actually dealing with the hydro parameters, right? For instance, temperature, pressure, and these keep on changing. And you may find that the design of the process today will have to change after 5 years, meaning what applied 5 years ago may not apply 5 years later. Is that true? So there is that concept of continuous improvement.
That I believe is correct.
It is correct.
Let me think about the question. You are saying in CFD simulations, we have to apply with the boundary conditions, either it's temperature or pressure. And in a chemical process, a pressure can be varied. And then what? Can you repeat your question?
What I'm saying, ideally, for any process, the parameters keep on changing. And the point reaches, because of reasons as maybe the changes in the process, the conditions, the temperatures, the pressures, and the material of construction, it would necessitate maybe changing the design of the process at some point. Okay? So what I'm trying to ask is, do you think the model that was done 5 years ago would still apply after 5 years? Or there is need to do another study and update that model? Because just a moment. Because I'm looking at, if the model is already existing, why should we have CFD engineers in the plant? Because we would rather have one and the model today for good and use that model until. But we have CFD engineers being employed to keep on checking, which drives us to the concept of continuous improvement.
Yes.
Right?
Yeah, that is correct.
That's correct. Now, to add on that, there is what we call value engineering. Do you know something about value engineering?
Value engineering?
Yes.
No, I don't think I know that. Value engineering. Do you mean validation engineering?
Value engineering is a concept where which helps companies to optimize costs.
Yes.
From an engineering perspective.
Yeah. Yeah, I'm familiar with that job description. In many fields of process engineering, they will do a value evaluation about how to reduce the cost and how to achieve the industrial goals. Sorry. Either it could be the target product concentration, or it could be a target industrial production rate, or it could be minimize the capital cost, electrical cost, power input cost, and how to slowing down the process of the equipment fix. Yes, so I'm aware of that role.
Yes, so I would like you to give us a scenario where CFD is considered as a concept for value engineering.
Good question. I think in so many ways, CFD can be a great help for value engineering. The number one, the first thing comes into my mind would be how CFD techniques can be employed to improve the current techniques and determine the optimal working environment conditions. For example, like for distillation towers, because the flow itself is highly mixed and their concentration profiles in the inlet is higher, in the outlet is lower. And when the vapor phase is going up from the lower tray, there's not enough mixing going on. And saying we can improve that by using like a cap tree or a sieve tree. And it would be cost a lot if you're doing the mechanical experiment. But the CFD can do that, right? You just varying those aspects, varying your geometry design. You don't have to manufacture it. You just need to simulate that. Get a result, find out the best one, find out the principle of why it improved the separation of the chemicals. The second one would be considering the optimal operation parameters at what temperatures the fluids goes best, the separation goes best, at what pressure difference the separation goes best. Again, it's pretty hard to do a mechanical test, but a simulation gives you the opportunity to reveal those with an accurate model. And once we identified that, then we improved the scale of separation with hopefully a little bit, not much more cost. Therefore, with the same money, we produce a higher end. With we produce a product with a better quality. Or saying that we can use CFD tools to analyze what will happen if we increase the flow rate and find out a good trade-off point. And at that time, the result could be we can increase the production rate by 15%, but the quality only goes down into like 0.5% and totally acceptable. And therefore, we achieved a better goals with the same money. And CFD tools can help with value engineers, those aspects of it. Yeah, that will be the two things comes up in my mind.
Great. While you worked as a process engineer, did you encounter a challenge of cavitation in fluid flow?
That is a great question. So I got this job as an intern, and it's a rotational position. So we went through process engineer, R&D engineer, and some other kind of role. The project I participate mostly in the process engineer because I was desperate to learn the chemical process. After I just graduated, I know about like nothing about how the real world refinery plant would work, and a process engineer and reading the PID figures help me to understand how things works in the real world. And in terms of why I went into the CFD world, my PhD degree is that I do think CFD is a very unique combination of so many disciplines: physical, mathematical, PDE, linear algebra, control theory, and software engineering, high performance computing. And therefore, it's fascinating me doing this field. And actually, CFD, another big reason for that is um, I'm crazy about um, aerodynamics and how the planes fly in the air. And so that's the other reason I choose the CFD over the process engineer. But I still love process engineering as a job very much.
Well, I've understood you. But one of the challenge that we encounter during fluid flow is cavitation. I don't know if you have an understanding of what it means. Cavitation.
Yes, the challenge I
Yeah,
encountered.
cavitation.
You're asking
Yeah,
challenge I encountered in the CFD simulation things.
cavitation. You know it?
Yes, I know it. Um,
But tell us what it is, what causes it, and what are its dangers, and how do we minimize cavitation?
no, I don't think I understand the question. You're asking
What is cavitation?
what is
What
computation?
what is cavitation? What causes it? What are its dangers, and how do we minimize it?
So you're asking what is computation?
Cavitation, cavity.
Computation,
Cavitation.
confidation,
C C A C A V
CL,
I
VI.
T. You can check in the charts.
Okay.
Check in the charts.
Oh, cavitation. Cavitation
Yes.
is let me think about it. Cavitation. Good question.
Maybe to give you a brief background about cavitation.
I think I know that. Can I continue to answer the question? Cavitation is something like it happens in a turbine or a compressor that has a propeller rotating very fast. And at that time, because it's the speed it rotates, um, some of the fluid may be vaporized, getting little small bubbles. And the bubbles will interact with the surface of the propeller and it breaks up. Creates a rapid pressure change. What happens is it will actually damage the surface of the propeller. It could be in a turbine, it could be in the compressor, or it could be in the propeller in a submarine. And you're asking how do we overcome it, right?
What are its dangers, and how do we overcome cavitation?
Yes. So I introduced the concept and background. How do we overcome it is that there are ways to reduce the cavitation. First, to get a smooth surface. If the surface is smoothed out, the damage due to the cavitation can be reduced. Second way is that you can put a a baffle around the propeller that redirects the flow, and therefore the bubbles, the damage due to the bubbles breakup would be minimized. That's how a certain submarine is used to reduce the cavitation and the noise. So that's the two methods that come up into my mind about how to reduce cavitation.
Okay. Dr. Chen, I would like to say, I think at that point, we can stop the technical questions. Maybe for Hassan has something to add on, I would like to go on to another perspective, another area of interview. Please, Hassan, you confirm if you have something under here on technical competence.
Yeah, so you're asking if I have any other questions about the technical questions?
No, I mean, Hassan, if you have something to point out.
Oh, understood. Yep.
Okay, I've seen. So, Dr. Chen, we are going to look at change and leadership. As chemical engineers, it is quite important to understand that we are leaders. And today, the business environment that companies are operating require that everyone in their capacities should actually be leaders. We do not leave the leadership role to those holding managerial positions. And when it comes to leadership, it essentially means being influential at whichever level you're working. You agree with me?
Yes, I agree with you.
Thank you. Now, from your experience, I would like you to share with us a scenario where you exhibited effective leadership potentials, citing examples where necessary.
Yep. So during my PhD degrees, I supervised several undergraduate and graduate students that working in our team. And I worked as a small team, and I think I was the leader of the team because I was the one assigned tasks and evaluated their performance. Once upon a time, there will be four members in our team, and we were working a CFD research group. So I'm not. I would like to keep my hands off our project. So saying, I know the details about the project, but I don't need to go through all the details. But I always make me available and make my team members know they can find me at any time if they got questions or confusions. And what we do is we make up a very short meeting per weekly to overview what we have done in the last week and the goals that we want to achieve in the next weeks. And there was a time that we have a pretty tight timeline of achieving a project goals. Um, so I was helping them to clearly identify the problem, and we did a brainstorm about how to attack the problem. And finally, it's a technical issues, and finally we have solved it. Um, and we were very happy about it. It was how to run a new CFD package on the Linux system that has a weird commands going on, and the software environment is messed up, and we assigned the tasks and helped cleaned up the environment and made the program run on Linux. So that will be an example that how I lead the team, showing my leadership and achieved the goals.
Dr. Chen, from that example that you provided,
Yes.
I would like you to point out what are those key ingredients that a leader should have in order to succeed, like you succeeded, as you've said.
Yes. There are several things. A leadership should have a clear picture about the team. Leadership should know that everyone is different, and therefore the response for different people of the under the same situation, they're different. You have to understand that why they behave different, and cooperate and work with that. Our leadership should be a great team player. You have to do your best to make your team as a well-oiled machine that work together as a team. Leadership should be, let's see how to say that, should have a good time management skill, that have a clear picture of the timeline, deadline, and the trailstone, um, and a good leader should be being helpful, giving the understand the team members what do they need and what can you do to offer what they want to have. For example, if a team leader does not have any CFD background, it would be my job to point him or her the necessary materials, probably several useful websites, background, textbooks, YouTube videos about CFD, and help them to get in the zone quickly. Other than that, I believe a good leadership should be a socialized person. It would not be like 100% focused on the work and totally disappear when off duty. It should be maintained contact with your team members and understand what they are going through. And also, I think the most important thing is as a team leader, you have the power, but you have also take the full responsibility if the team does not meet the requirements of the company. I think the leader's responsibility to take that.
You've talked about working in a team, right? What's your understanding of emotional intelligence? And what is its impact if not well managed?
Yeah, you bring up again. Can you repeat it?
Yes, is one of the key determinants that ensures that if a team is to actually succeed, it has to be well managed, right? Emotional intelligence. As long as you're working within a network of people, you have to understand and its impact if not well managed. You understand what emotional intelligence is?
Yeah, is that how you manage your emotions like anger or desperation? Like emotion management?
Yes.
And you want an example of how I handled it, or you just want
I
me
want
to?
you to tell us how emotional intelligence is very important when well managed, and what is it if you don't manage it well.
Yeah. So it is very important to management your emotions. Most thing would be desperation, anger, anxiety, sadness. Um, Not only because it will help you feel happier, but it will also makes your team working in a healthy environment. Some common ways of the emotion management would be cognitive behavioral treatment that you can write down how you feel, analyze why do you feel it, criticize the logic chain about the reason why you feel it. If someone does not have the required management of his or her emotion, things will get bad very quickly. You won't have a good communication with your team member, your boss, or your clients. One thing. Second thing, you might develop some kind of mental illness like depression disorder or anxiety attack or panic attack. Third is that you are hurting the environment that other people are working under. So I believe that effectively managing your emotion is critical as you're dealing with yourself or any other people.
Good. Now, as a leader, uh, how do you ensure that your team does not diverge from the overall goal and actually contributes to the overall objective of the corporation?
Yes. So if I were a team leader, the ways that I ensure that what my team contributes is not diverged from the overall goal of the company would be, first of all, you have to have a clear picture and a clear definition of what the goal is and what we want to achieve. And it could be something that it could be best if we can quantize it. For example, improve the production rate by 30%. Then we have a key index that we can guarantee we're not off the track. The second way I can think about is to constructing a regular group meeting so that we can discuss what the goal is and what we have achieved right now and where we are right now and how we can make positive towards the goal. The third one would be assign clear task. It could be like I'm assigning task to A to figure out a way to do this, but I won't assign a specific details of how we would achieve that. we will help him achieve that if he does not know, but I would not go over um, the basic things that he need to do. I will just assign the goals that he has to achieve. And as a whole team, that we will finally make sure that we will not deviate from the goal that company has. So that's the three things that comes to my mind.
Well, from your previous experience, tell us a situation where you failed to achieve or to deliver as a leader. And what are those key lessons that you learned from the situation?
Yep, great question. I think I would like to share one of my experience. There's another professor in a different department want us to do a CFD analysis of a filter cascade. It's a filter located in a device, and she wants to know how the flow would be after the filter. We would assume that the filter itself would be clogged after a certain time. So I just went up and write out a custom program to model that. Later on, we find out that the filter itself is not clogged after a long time, no matter how much pressure gradient you get. Therefore, we were unable to deliver the simulation result for her. The lesson would be that we have to first have a clear picture of what we are modeling and what problem are we need to solve. And doing the experimental validation first, make sure it's the situation, and then start writing the code and developing the program. Otherwise, it just could be kind of a waste of time. You develop a fancy program, but it does not do anything. It's not realistic. It does not help with the real world process. So that is the experience, and the lesson I learned is to clearly define your problem first, then try to attack it.
Okay. Now, today, as you may understand, the rate at which the business environment is changing is so high. So organizations are required to cope up with the requirements of the changing environment, which among others will include the regulatory requirements, for instance, health, safety, and environment requirement standards. And at the same time, organizations want to be profitable, right?
Yes.
This drives us to the concept of sustainability,
Mhm.
which looks at three major issues: social sustainability, economic sustainability, and environmental sustainability. So the world forces are requiring most of these organizations to ensure sustainable operations. Okay?
Yep. The
Now,
question. Yep.
now, as a CFD engineer, I would like you to tell us, how do you hope to help the organization ensure its sustainability?
Yep. That is a great question. Let me think about it. I believe one thing is that we can use safety tools, developed a new and improved process that helps with the sustainability of the company. Um, for example, in my last project, research project, we were making biofuels from microalgae rather than the fossil fuels. So it's make the world itself more sustainable. Um, Another example could be like using CFD tools to establish new work process and a system and share a commitment to sustainability that may make the company much more healthy and goes better. That is my answer.
Okay. Now, as we close the change and leadership competence assessment, there is this misconception, or it's a confusion rather than ideal practice about a manager and a leader. Kindly assist us to understand the difference between these two concepts.
Which two concepts?
A leader and a manager.
A leader and a manager.
Yes.
That is a great question. I need several seconds to think about that. I guess to be a successful manager and a good manager, you have to work like a leader. The goal for a manager is he has to manage his team. The requirements for a manager is that he has to manage his team and working together in a healthy environment, collaborate to achieve a certain goal. There are additional requests for a manager, but as a leader of in a team, you will lead the team um, as a team player. So I believe the difference of those two concepts is that to be a good manager, you have to be a leader. And there are more requirements for a manager rather than a team leader. Like you have to do the assigned tasks, retrieve certain index, retrieve certain commitment you have to achieve to the company. But as a leader, it would be like leading your teams, making forward progress. That would be my answer.
Well, at this point, I would like to say we have come to the end of the change and leadership assessment, and we shall be moving on to the behavioral, and it's the last part. I don't know if you need a few minutes to refresh,
Yeah.
one or two.
One is enough.
Please.
I will be back in 30 seconds. My cat is coming out.
Hey.
Yeah, let me feed my cat first. It's 7 a.m. here. Okay, I'm back. Let's go through the behavioral question.
Oh, thank you. Welcome back.
Yep.
Well, we have interacted. I think now you know me, I know you.
Yep.
Hey, do you think you really love working with people?
Yes, I'm enthusiasm people, and I'm a great team player. I love to working with different people with a different background. In fact, that in my past role, I worked with people from mechanical engineering, electrical engineering, computer science, biological biology department. I understand they have different backgrounds, they have different opinions, but it would be a great opportunity for me to learn that their discipline. So yes, I love working with.
Now, you see, in ideal setup, we interact with people. That's why I've decided to talk about this. We interact with people, both technical and non-technical.
Correct.
I want you to tell us a scenario where you had to communicate your CFD model or results to a non-technical audience.
Yep. Great question. I think the way I would communicate would be use less technical slogan, but more plain words. At the end, it's you describing a result regarding to a phenomenon or to a certain situation. If I'm talking with the technical person, I would use the precise technical words so they can understand what I'm talking about, and use the data they are interested about, like the key data that are representing our result. If I'm communicating with a non-technical person, I will use plain words to describe my simulation result and make sure they can understand it. And I would also make it fun for them to go through it. What I will do is instead of numbers, prepare figures, videos about how the fluid moves and try to explain it during my communication if I'm talking with the non-technical personnel.
While talking to a non-technical audience, how did you know that they have understood what you're trying to communicate?
Yeah, my own trick would be ask them regularly, like if they understand it, do they have questions about it, and ask some questions that is not a yes or no question. That's the first thing. The second thing, I will take baby steps towards it. Like I will introduce the background thoroughly and make sure they can understand. The third one would be make an analogy and examples to the common things in their daily lives to make sure they can understand it.
So you constantly sought for their feedback.
That is correct. Yeah, feedback is critical of communication. It's two-way communication, not just you're talking, they're listening, but they're communicating.
Okay, so as a PhD holder, don't you think you're overqualified for this position?
No, I do not think I'm qualified for this position. So this position, first of all, in the job description, it requires you have a PhD. And second of all, that I believe that it requires you to do some research experience so that you can understand how a research project goes. And you can gain a certain personality through your PhD degrees and the lessons you learned to be successful in this role. For example, it would be maintain your enthusiasm. PhD degree, this program is a long program. It's so easy for many of us lost interest or lost the ambitions at some point. But to be successful and graduate from this program, you have to remember that what's the initial goal is and what your dream about, and it requires you the hard working and continuous effort to be successful. And so, no, I do not think this overqualifies this position. I believe the PhD programs teach you so much things so that you can be successful in this.
So what specifically attracted you to apply to this position and to work for this company?
Yep. For myself, I believe the creativity is so critical for me, and I have always worked in an environment where I can have expressed my ability to innovate, and find my own solutions for industrial problem. Another reason for that is that I've researched the background of your company, and I very happy to find out that your company supports your development department so strongly. Um, so I would be extremely happy to work in this environment that for a company that values its development department. Um, yeah, so I have Googled it and figured out this would be an interesting job for me and a great job for me to apply for. So that would be my question, my answers for this question.
You try to tell us what you envisage as your working environment.
Say that again.
You tell us what you envisage as will be your working environment.
How my what as my
How do you see, what do you think, what do you think your working environment will be?
okay, what I hope my working environment would be. I I hope I will work with a great team, either being a team member or a team leader. I hope that the working environment of this team is big or small would be healthy, and I believe there would be a great communication with me or with my supervisor or with my team members. I hope there would be a clear goal for us to achieve instead of everyone just busy doing their things. Deviates from the goal of the project. And I hope it would be a safe and a healthy environment to work with, that the team or the company values the safety and health of their employees. And I hope it would be an environment that I can continually learning new things and new technologies and being updated to the latest technology in this field, and it would be helpful to my future career. That would be my answer.
Dr. Chen, in an ideal working environment, conflicts are inevitable. Kindly share with us from your previous experience a scenario where you had conflicts with either a colleague, your boss, or your subordinate.
Yes.
And how did you handle it?
In my previous working experience, I have conflict with my boss and with my colleagues as well. I think I will just give an example of the conflict with my colleague. During a previous program, I was working with another mechanical engineering PhD students that we found out there are common overlapped research interest during us. And that could be a conflict because we were doing the same thing and the overlap of our research goals. And if it does not handle it well, it will make the other person think that you're competing with each other instead of collaborating. The way I have used is to communicate with him, ask him to hang out a dinner in a restaurant so we can communicate with other open mind peacefully and tell each other what we really think and how we feel, the reason why we feel that. Result would be that although there are common overlapped research areas of me and him, we will agree that there are so many things we can do to make those things different. And the other thing is that we can actually collaborate the same project. We can group as a small team and trying to back up each other. And finally, we would work with a team and research together and co-author a project and a paper from it. So in that example, I used effective communication to turn out a potential conflict for collaboration.
Well, where do you see yourself in the next 5 years?
Yes, that's another great question. Give me a second. I'm not sure absolutely, but I think the most important thing would be I would like to continue learning and grow in my career. I'm kind of a person that I need continuous new challenge for me to be focused on my work. I believe I would have great experience and knowledge um, and to work as a fluid modeling engineer. So in 5 years, I hope I would be a senior fluid modeling engineer or a CFD engineer. And I hope I will grow together with the company. I hope I will have the key skills and knowledges to be successful in the senior CFD engineer role. That would be my question, answer to the question.
Okay. Kindly tell us what your strengths are and what your weaknesses are, and how are you working upon to improve your weaknesses?
I think my strength is the persistence and the flexibility that I have. I really like to work as a team player. I really enjoyed communicating and working with uh, so many people from have different backgrounds, different countries, different languages. It's always a pleasure for me to learn from them. And I am enthusiasm and persistence, persistent people. Um, I believe that my work ethic won't let me just settle for less than my best. I would like to try my best to achieve the goal. Um, I would like to face new challenges and setbacks without feeling frustration or anger. I can control my emotion. I can effectively find out the distorted and the non-realistic thoughts that I have, and make sure I will work happy in the environment. I believe my biggest weakness is um, public speaking in many in front of a great population of people. It's something that I have done a lot of time working on, which is getting much better. But I still face some kind of anxiety giving a public speaking in a great population of people. But at this point, I can handle this situation professionally. And what I like to do in the future would be I hope I will have the opportunity and the chance to continuously practice those skills like public speaking in front of a great population of audience.
Okay. As you can see outside there are quite a number of candidates who are waiting to be interviewed for the same position. I would like you to tell us why you think you are the best candidate for this position.
Correct, correct. So the first reason would be my that I'm qualified due to my experience and the certification I hold. I would be qualified for the job description. Um, I have been in the CFD fields for so many reasons that I gained the knowledge and the skills that not only fulfilled for this role, but any other insights that will help this role, that will help me to be successful in this position. That could be the machine learning, AI, or the data analysis and the programming skills that I hold and my fundamental understanding of computer science. Another biggest reason is that I am enthusiasm and a great team player. I love to be, uh, I love to work with my team, and I held a great skills in terms of emotion management and effective communication. And thirdly, I'm an organized person that I have a clear mind of the timeline and the goals that the company wants to achieve. So I will make sure that I will stay focused and not deviated from the goal that we want. Yeah, that would be my
Okay.
answer.
All right. So from your explanation, there is where you pointed out that you like meeting new challenges, right? There's somewhere you said like want new challenges. You're someone who wants challenges, right?
That is correct. Yes, I want new challenges. And
Yes. I would like you to tell us from your previous experience. You can single out one challenge that you faced from your professional environment, and how did you overcome?
yes, unfortunately, yeah, there are major challenge I had to face my previous role. I'm a CFD guy, so we did a CFD simulation of a system that we're interested in a open pump system. And for a CFD position, you have to validate your CFD results. At that time, we don't have enough money to buy great velocimetry device to measure the flows. And we had a hard time of locating a device that some other professors in the university owns that we can land to do the measurements. So we have stuck for a little bit of time. And then I decided to design my own and manufacture my own velocimetry device. I learned C++ programming. I learned microprocessing unit. I got a little background of electrical engineering. And I brought a milling machine from Harbor Freight. And we have designed and manufactured and successfully employed my own designed device to measure the velocity field to validate with CFD.
Okay. Now, today, organizations are constantly demanding for efficient delivery from their staff. And as such, there is always that need to beat deadlines. So we would like to know from your previous experience, a scenario where you had to beat such a deadline and how you effectively delivered the required output.
Correct. Could you repeat your question again?
What I'm saying today, there is stress to deliver. There is always that constant pressure from our supervisors to deliver output. So share with us a scenario from your previous experience where you had to beat a deadline, but you delivered and the right output.
Right. Yes. So you're asking how I beat up the deadline and work under pressure and finally delivered it. I believe that would be the one goal is that we have scheduled my dissertation, my defense in October, that I still have a TA and other work needed to do during my final semester. So we have a strict deadline of that. At that time, I have to write out my dissertation and my paper and be prepared for my defense. So what I have done is I write out a clear timeline of what I have to be achieved each day, and I break down the big task into small tasks, so that is not that scary anymore. Something that I am capable of doing every day. The second thing is I talked to my boss, my advisor, expressed my concern, and asked him for help for like constructing a dissertation, it requires a healthy and effective communication with you and your advisor, so that different versions of your papers and dissertation can go back and forth, and you can iterate further from that. My advisor was extremely helpful. We worked as a small team together. I revised my version, handed it over to him. He will give my comments, revise again. And he gave the valuable advice on PowerPoint and the presentation with me. And I take it very seriously. And I believe it's the key factor that I will be successful in my final defense and earn my degree. So that will be an example of the pressure I faced and how I worked with my advisor to overcome with it.
Okay. And I think my last question, why are you leaving your current job?
Why do I leave in my current job? So my current job is academic research assistant. But I'm a hands-on guy that I love building and designing new things. The reason for my intention to go to the industry from the academic area would be that I believe that in industrial, you can work in a bigger team. And that's the first reason. The second reason is that you can work with a bigger project that have the real impact of people's lives on the research for the in a research project in the university. Although they are great projects that would need 20, 30, 40 years for them to make real impact to people that I care about. The third reason is I think the things that an industrial company focus is different from academic research team would have focus. For example, for industrial, they would focus how to lower the cost and how to one device last forever. For a research team, they will focus on the high-end device, but does not care if they will break in next week or not. They just want to have that device to get the new knowledge about an unknown field. I believe I would be a better fit into the industrial, because I think I'm more interested about like how to achieve things and goals effectively, affordably, and make impacts that will have an impact on the people that I care about in the near future, not in the next 50.
Okay, what are your salary expectations?
I've done some research, and I believe the correct market for this role would be 90K to 100K. So my expectation for the salary would be like 95K.
Okay, do you have any question for us?
Actually, I do have. For example, say if you're looking back at this hiring decision you made, and you find that you're extremely satisfied with the person you hired, what skills or personality will he or she preserve for you to be satisfied with him? The second question would be like, I want to know there are how many people in the team, and my daily working description in this role, and how I will be evaluated, and will there be a KPI for me, and how often will I be evaluated? That's the two questions I have.
Okay. The first question you asked, I think the second question I will ask Hazard to come in. But the first question you asked, what are those qualities, right?
That is correct.
Yes. Attitude is very important. Your attitude, we look at your attitude, and we look at your confidence. Confidence, look at your character. That's your personality. Sure, everyone comes and they are technical, but what distinguishes are those three: character, attitude, and confidence. We believe the rest can be trained. Yes.
Okay. Awesome. Thank you for your answer.
So with that, I think, Hassan, do you have something?
Yes, Bernard and Chen, thank you very much. You both uh, performed in your own ways very well. Like Bernard was performing the role of an interviewer, and Chen was the interviewee. So I've been watching all around the questions which Bernard has asked from Chen and the response of what Chen has given to Bernard. So in my views, it was incredible good. Uh, Chen, I have one question for you. Do you know about ethics and compliance?
Aesthetics?
Uh, Check out the chat. I'm writing in the chat.
Awesome. Yes, I do not like that. Yeah.
What is it? In your own views, can you describe with an example?
My definition for aesthetics is you have to be an honest, honored, and a loyal person with your team and your company. Very well, a great example of a conflict or a violation of the ethics would be like if I'm if someone is working for his company and he leaked his data without permission, or he leaked his idea, or he is talking with another company about what they're doing without the permission of his current employer, that would be a clear validation. Sorry, a clear uh, that will break the ethics for me. That will be an example, like
Okay.
sharing thoughts.
Yeah. Yeah, it's like, for example, you are doing a job in a university and you get hired by DuPont, but you do not mention your job to the university and still going with the two jobs. That also considers under the umbrella of ethics. So Bernard, thank you very much. If you can give Chan live feedback of the shortcomings and the room for improvement, as well as the areas in which Chan performed very well. So it would be great from your side.
Yes. Yes, thank you. I would like to give honest feedback. First, I want to thank Dr. Chen for attending this interview. We assessed you under three categories: technical, change and leadership, and behavioral. Under technical, you're very good. Very good.
Oh,
and the way you drive your answers, you're not always straightforward. You come from first principles, which is very good. You bring the background before you actually give the right answer. Yes. I like that. That's very good. Those are because of the time, depending on how many opponents we have, it's good to be very precise to manage the time well. Okay, the time management is very important because you may find maybe you have less than 1 hour to do the interview. So it is quite important to be very brief, precise, and to the right points. But always from first principles is very good. I see. So under technical, you're very good the way you come up with your answers. I liked it because you see sometimes we don't mark correct answers. We mark the way your approach is very important. Then under change and leadership, just a small thing you need to improve. Yes. I just need to give yourself time to understand that concept. Make sure, because as an engineer, you are a leader. That's by default, you're a leader. And the leadership is all about understanding the vision, and you're with the team, managing change, and knowing which resources to achieve the goal and how to allocate them. It is very important because as a leader, you must deliver. You must keep your team directed to achieving the overall company goal. So there's just something small that you need to improve. Right. Especially when it comes to sustainability from an engineering perspective. It is very important. Then under behavioral, you're very good. You're very good under behavioral.
Well, thank you.
So generally, you're very good. You just need to do continuous improvement and you'll be excellent.
Great. Thank you.
I've liked your confidence. I've liked your confidence and the way you don't rush to give answers. And you keep that eye contact as you explain. And then at the same time, you're moving your hands to illustrate. It is so good. Please, when you do that, I believe you will get outstanding results if you improve on a few things.
So, do you think, like, out of 10, how much you will score it?
Above 80.
Oh, thank you.
Yes.
And let me repeat your feedback. So I need to improve on the time management, make the answer short and brief and concise. And for the leadership part, I have a misunderstanding of the concept of leader and manager. And I need to reveal like how a company would do to make sure to ensure their sustainability. And for the behavioral, seems like it's okay for now.
Yes, it's Great. Okay. That's from me.
Yeah, Chen, yesterday, we had a session and I've given you some tips later night yesterday when we had an interview session for around 1 hour. So I see that the tips which I've given you, you very well adopt that and like the one the eye contact and the movement of your hands and the confidence you show your camera directions. So all all of the things which I have analyzed during an interview was really good. And best of luck for your interview. And if you have any questions from us, then you can write it down on the chat, as well as you can contact us before, just before the interview or the after the interview.
Great, great. I think, yeah, I don't have further questions regarding to the mock interview.
So you can also give us the feedback live. And how do you feel this mock interview initiative?
Great. Yep, I will do that as well. You want me to give it right now or?
I think you can do
Yeah.
later. There is somewhere I would like to go. I will get the
Okay.
feedback through Hassan.
Cool.
Okay. Thank you, Bernard, for giving us time, your precious time, and you have to go somewhere, but from your um, scheduled meetings, you have given us time. So thank you very much. And thank you very much, Chan, for attending this. Um, all is well if and is well.
Yep, it's
Welcome.
same for me. Yep, thank you for providing this service and helping me go
Bye.
through society. Bye bye.
Bye bye.